Thanks. I don't have to keep my mask on. So let's have a look. Right. So this is HSI 1000 or SI1, as you should be aware, right? It's of course part of the common curriculum. And the common curriculum, which you've surely been shown already on many occasions, is made up of all these modules here. And this one down here is SI1. So that's what I'm talking about today. Okay, so this particular module is a singular module. It means that the entire cohort of arts and science has to take this one module. So that means the class size is about 1,100 students or 1,100 students for this one single module. Now, this is our biggest LT at NUS, and it can only take about 750 students. So there's no venue we have here that can accommodate that. So all the lectures for this module are online, whether it's pandemic or not pandemic. All the lectures are online because that's the only way we can deliver the content to you. But the entire module isn't just online, just the lectures, okay? Now, here are the profs that have been involved in developing this module. Yours truly is up here, and each one has got certain different roles within the module. The three main lecturers are, though, is this fellow here, this guy here, and this guy down here. So you'll be, if you're taking this module this sem, or this coming sem or next sem, these will be the lecturers for your module. Okay. As I mentioned, the lectures are online, but we have a bunch of face-to-face activities that we have in order to reinforce the lecture material. There's no use, as you probably know, just sitting in front of a video and watching a video. You will probably not learn all that much. You need to actually engage with the material, and that happens with some of the quizzes that occur after the lectures that are online, but mostly in the face-to-face activities. Now, these people here are the full-time teaching assistants that we have, quite a large group, because there's a lot of students that take this module. Okay, now this guy here, Yi Hong, is sitting right at the front here. He'll be talking a little bit to you after I finish, which won't be that long, in a few minutes, about some of these face-to-face things that you'll be doing, right? So we've got 3 workshops. We don't have tutorials. Tutorials are too short. So we have 3 workshops. They're technically 3 hours long, but more like 2.5. An exploratorium, he'll talk more about that. And there's a field trip as well. It's a self-guided field trip in which you'll go to, well, he'll tell you more about that when he gets on stage. Okay, so what's the module about? Well, before I get to what the module's about, let me ask you, this is a rhetorical question, you don't need to actually answer me. What is science? Now, I think if you ask someone, especially A-level students, what science is, they'll tell you a bunch of things that is associated with subjects. They'll talk about physics, chemistry, maybe mathematics, right? Pharmacy, medicine, these things. They'll say that's science, right? Subjects. The thing is that really science? I mean, those subjects are actually an output that science has produced, okay? In a sense, it's not actually what science is. It's something that science produces. By doing science, you get all of this knowledge, and the subjects that are up here is that knowledge. So science isn't so much the subjects, it's more of an activity. Science is an activity. In fact, it is that activity, right, as it says up here, which aims to further our understanding of why things happen in the natural world. That's what science is. Okay, so the focus of this module is to be more on this. Now, of course, science students might be wondering, well, why am I doing that? I'm a science student, I know this already. We'll see, okay, we'll see. We'll get to that in a moment. Okay, so that's what science is. It's an activity. It's finding out why and how things work, okay, and finding out what doesn't work. Okay, so it's a big part of the module is scientific literacy. Make sure everyone's up to speed with what is science and how to use it. Okay, we do that by looking at how it works and why it works. Now, as I just said, a lot of science students think that, you know, this should be a breeze for them. There's something they know already because they've done all this science at school. The thing is, what you've really done at school is you've learned about the output of science. You've learned about the things that science has discovered. You haven't really done very much at all on how we know what you're told in those textbooks is true and how we know what isn't true. You certainly haven't been told all the mistakes that were made along the way, even for simple things like heat, right? And the theories, all the different theories that led up to our current understanding of heat and things like that, that hasn't been mentioned before. So science doesn't have all the answers. A lot of students will come to me and say, you know, especially when I teach in chemistry, they always want to know what the answer is. Well, especially if you're at cutting edge research, we don't often know what the answer is, but we have a good idea, but it doesn't have all the answers and it never really will. But at least we can find out what isn't true. Okay, so we'll be teaching a lot of this in this module, okay? And the example that we'll be focusing on to help teach how and why science works is climate change as well as biodiversity loss. Okay, so those are the examples, because you can't really talk about how and why science works in a vacuum, right? You need a specific example. So that's the example that we'll be doing in this module. We'll also be looking at how science interacts with society and how society also influences science. So, sorry, I've got a bit of a sore throat now because I was shouting outside wearing that mask and I've kind of lost my voice already. Okay, so sorry about that. But we'll be talking about how science is influenced and influences society and how society in turn influences science. And it does. A lot of people think science is pure, that politics doesn't have any influence on science. Science is what it is and what it does. Well, it's not really true. There is definitely an interaction between the two, and we'll see some of that, especially when we talk about the climate change part of the module. Another thing that's really important is that science is, of course, everywhere, and it's used in our daily lives, and we'll see plenty of examples of that, of where science can and is used in our daily lives and how you can go about using science to help you get through and come to answers for questions that you might have in your own personal life. And it might not necessarily have to do with the subjects of physics and chemistry and those sorts of things. Now, the module isn't about teaching domain content. What I mean by that is we're not going to be teaching things like Newton's laws of motion or the laws of thermodynamics or I don't know, black body radiation or some other quantum mechanics. No, that's not what this module is about. That's what the majors are for. That's what the majors are for. You learn that in your domain-specific majors. If you're not a science student, you don't even care about those things. This module is about how and why science works and how you can use it in your life to make your life better. And as we'll see in a moment, how you can use it to not be scammed. How you can use it to not be scammed. Now, why did I put this up? Defense against the black arts. We are teaching that in this module. And what is the black arts? The black arts are liars, cheaters, scammers, con artists, email scams, phone messages that are full of nonsense, right? That are out there meant to trick you or even steal money from you. You can use science to at least be warned that what you're looking at is highly suspect. Okay, now there's a toolkit that we'll be using. It's called the Baloney Detection Toolkit that you'll be using, and it's based on science, and you'll be using that, and we'll be having examples of that. It's in the workshops, it's in quizzes and things, to at least get you to start thinking about how you can determine and differentiate between what's credible and what's not credible, with information that's been given to you in social media and all over the place, right? So there, instead of Hogwarts, it'll be NUS. Okay, before I finish, these are the actual lectures. So these are the online lectures. Of course, they'll be updated probably for next sem. So don't say, oh, sir, can I please get these lectures now so I can have a head start for next sem? No, because they'll probably be changed. But the lectures, we've gone to quite a bit of effort to try and make them a little bit more interesting than just simple a talking head in a video. So they're in something called, each lecture is in something called a sway. It's like an ebook, right? So here we are, the very first lecture, of course, the founding of modern science. That's what you should learn from this particular lecture. There's some detailed notes here. Always trust this. I won't try to scam you, okay? And then you can go up here and you'll see all the lecture notes. Yes, very lovely. Right, so all the material from the modules there in the lecture notes. And then there's, of course, me posing in various funny stances on that. This is an example of PC won't work. This is an example of the scientific method. That's how science uses, and that's how science works. So the very first example, that's a very real world that you can see, is an example of the application of the scientific method, right? In a nutshell, observe, explain, and then test the explanation. We use that in troubleshooting. Troubleshooting is an example of the scientific method, and you can, of course, use this in your own life to figure out what's wrong with your PC. Then we have an example more in line with nature, where you can look at a tea bag and make some conclusions about what's happening there, right? There's the video, then you've got some questions after the video, and then we have an actual example dating back to the 19th century in medicine, something called cadaverous poisoning, puerperal fever, where the scientific method was used to figure out that doctors should actually wash their hands before they operate on people. Okay, well, not really, well, yes, in a nutshell. Right, then we talk about observe. So this is what the lectures are like. So we've gone to quite a bit of effort to make them engaging for you and interesting. That's for my part. It's taught in 3 blocks. Here's another lecture. This is from Prof. Adrian Lee's part of the module, now on climate change, applications of the scientific method. Let's just change it so I can scroll it. Okay, so again, it's the same sort of thing, intended learning outcomes. He doesn't necessarily give nice PDF file for notes because you can save this as a PDF itself and that then becomes the notes. So he's talking about how a lot of uncertainty was, well, politics essentially was used to stop people from believing in climate change. Anyway, that's that particular lecture. So you've got all the lectures will be in this form, right? Except for these 2. These are online webcasts, right? More traditional style of lecture. The ones on biodiversity in Singapore, very local context for application scientific inquiry. Okay, so the module integrates all the different areas of science. It's in the integrated pillars of the common curriculum, and that's basically the content of this lecture content of this module. Okay, so at that point, okay, I'll hand over to, this is the very first workshop, to Ng Yi Hong, who's one of our very good FTAs, and I'll let him continue.
Thank you, Ryan. Yeah, so a very good afternoon to one and all. So as Ryan has mentioned, I'm one of the 8 full-time teaching assistants that's involved in helping to teach this module. In particular, we run the 3 workshops as well as an exploratory lab. So in this short presentation, I will give you a flavor, a taste of what you can expect to learn from these sessions. So let me talk a bit about workshop 1. So in workshop 1, this is not an exhaustive list of things that you will learn. After all, the workshop is 2.5 hours, so there is more content to it. I'm just listing out a few important ones that I think are relevant. So one of the things that you will try to understand is the importance of using citations and paraphrasing in your own essays. So at this point, you might be wondering, why are we actually teaching such simple stuff in the module? Okay, but you'll actually be surprised that actually during the workshops, when we actually quiz students on why do you actually do citations, why do you actually paraphrase, and if a certain type of writing actually constitutes plagiarism, many students actually have the wrong ideas of these important aspects of writing. So I would say that actually students actually did learn a lot and took a lot away that helped improve in their writing. So after all, right, like writing is a universal thing, regardless of whether you're from literature, geography, chemistry, or physics, you need to be able to write well in order to convey your ideas. Okay, so I would say that regardless of whether you're from FASS or FOS, there's something in it for every student. So one of the other things that you will learn in this workshop is with regards to fake news and online misinformation. So as we know, right, in this digital age, there's an explosion of information online, and it has been incredibly difficult to read a source and to judge whether it's credible and reliable or not. In fact, I kind of like fell for one fake advertisement on Facebook when I tried to purchase something, right? Basically, I should actually pass the bill to Ryan because he didn't teach me the baloney toolkit then, right? So, okay, anyways, like we will arm you with a baloney detection toolkit as Ryan has mentioned, and it will allow you to check if a source is credible and trustworthy or not. We believe that this is an invaluable lifelong skill that every student should graduate with because it will help you from your day-to-day life, as well as your future own learning journey, as well as your work life. Okay, so that's for workshop 1. As you can see, the title for workshop 1 is called Busting Bullshit because we want you all to be able to see through the information, the sea of misinformation online these days. So workshop 2 is on climate change, which Prof. Adrian Lee will cover in his second block of the module. So among the many things that you will learn in this workshop, one of them is to construct like simple modeling and to use it to make predictions. So I would just like to point out at this point that modeling is something that is not exclusive to science. For example, if you talk about economics, right, there's like models of demand and supply. If you go to engineering, there's actually models that help to study aerodynamics of plane flying. So it's something that's not exclusive to the Faculty of Science, and there's something to take away for every student again. So at this point, when you talk about modeling, right, like you all might be cringing, like maybe are you apprehensive about the mathematics that will torture you during the class? So absolutely, there's no such thing of sorts. Okay, in fact, the activity that we do is actually quite simple. You actually use measuring tapes to measure your arm length as well as your height. And the model that you will build is simply done using a software that everybody is familiar with, just Excel. Okay, and it's very like guided, so nobody will feel left out or left behind. Okay, in fact, I would say that many students actually enjoyed this activity thoroughly as they learn about the nuances of modeling and these predictions. And in my opinion, this is really one of the highlights of workshop 2. Okay, so the second point that I would like to mention with regards to this workshop is with regards to climate change. So as we all know, right, the weather these days is getting hotter and hotter. For me, like I can barely get out of my house without having to come back and immediately take a shower. So we really do need to deal with this problem. If not, like I'm quite sure we are going to melt along with the polar ice caps, right? Okay, so in this workshop, you will learn in a first-hand experience of how science can be applied to help solve this global crisis, as you learn of some of the current available portfolio of technologies that will allow us to make large cut in emissions of carbon dioxide. Okay, so that's for workshop 2. In workshop 3, as Ryan has mentioned, it will be taught by Prof. Siva, and it will be on the ecological side of things. So one of the things that you will learn is to use collected data to contrast between nature reserves and nature parks. So students will be embarking on a field trip where you will be visiting different ecosystems in Singapore, collecting data, which is the starting point of doing science, right? You collect data, then you bring it back and you discuss and analyze those data. And this is exactly what you will be doing in this workshop. So these photos here, these are the great insights that students have come up with during workshop 3. So a point about, Ryan has mentioned that we don't conduct any tutorials. So other than the workshops being longer than the tutorials, right? I would just like to point out that in the workshop, we plan activities. You are the one that actively carry out these activities. And in the process, active learning is done by you all. We firmly believe that that is the most effective way for you all to learn about any given subject. Okay, so that's the way that we're conducting this module. So other than that, we will also be talking about the importance of ecological connectivity. So for this point, I'll just briefly mention that many cities are getting more urbanized. And with urbanization, there are more like concrete buildings and concrete roads. And because of this, you might not realize, right? Because between different patches of ecosystems, animals actually have troubles crossing from one patch to another patch. Now you might ask, like, why is this important? Why do we even care? So believe it or not, when you come to this module, we will try to convince you and provide you with the evidence that is important for biodiversity to thrive. Okay, so in this part, as Ryan has discussed, that is in this module, we'll also explore the interrelationship between science and society. So you will also look at how science guides government policy making that will allow biodiversity to thrive back in Singapore again. And this is of course evident by the more frequent sightings of like your otters as well as your roosters all around our garden city. Okay, so at this point, I have the team has made a collage of photos that have been taken by students that have gone on these field trips for this past semester. So sit back and enjoy this short slideshow. Oh, sorry, one more slide before. Yeah, so let me talk a bit about the field trip. So like I've mentioned, it gives you an opportunity to conduct citizen science. So what is citizen science? Basically, students like you all go out to the nature and collect the data before bringing it into class to discuss it. And you'll also be able to understand the ecological systems in Singapore better. So among the many field trip sites, one of them is Bukitima Nature Reserve. And this photo on the right actually illustrates, this is an actual walking trail that is recorded by a student from this semester. So you can see that actually when he starts his trip, right, basically he starts the app and then he will walk along this path and it's recorded using the app. And then he includes it in his field trip report. Okay, so as I've mentioned, we have put together a collage of photos that students have taken on this field trip. So we are going to sit back and enjoy this short slideshow. Okay, so other than the 3 workshops that we'll be conducting, we also run an exploratory lab. So this setting is in a physics lab. But again, if you are worried that you have been away from science for a very long time and we're going to teach you very in-depth physics concepts, right? Rest assured that that will not be the case. In fact, when we run the labs, right, like students, both from FASS, they are able to follow easily. That's the way that we craft out our content. Okay, so what are some of the things that you'll be doing in the lab? You'll be given the opportunity to think like a scientist and to explore. So like the word exploratorium here, notice that we don't really use the word lab. So the word exploratorium is kind of a place for you to explore. And what you will do is explore through a range of activities and experiments to validate some of the stuff that you were taught previously in school, as well as to learn new stuff. Okay, so I would just like to mention that science is evidence-based, it's evidence-driven. Okay, so for example, when like Prof. Adrian is going to teach you in the second block, right, on that, we believe that, you know, like humans, when we burn fossil fuels, we generate carbon dioxide, which causes global warming. You should be allowed to ask him, like, why should I believe you? Okay, so like in this lab, you'll be doing some experiments, and one of which is this, which will allow you to validate and to understand and appreciate why is it in modern day scientists do believe that global warming is indeed human-induced. Okay, so I would say that like students, both from FASS and FOSS, FASS and FOS, both enjoyed the activities very much. And you can see that even for these full-time TAs, when we first started doing these experiments, we thoroughly enjoyed it. Okay, so all in all, I would like to say that like science plays a critical role in modern development across a wide range of disciplines. So, and this is what we hope to teach you in this module. So on behalf of the team, we look forward to having you all this coming semesters. Okay, so that's all I have for my presentation. And if you have any questions, Ryan and I will be happy to address them.